All right. Hi. Today we're gonna go ahead and do the notes for 2D, which is find a quadratic from its graph. All right. So with this section, we are going to write quadratic functions or equations based off of given a graph or a description of the graph. All right. So before we get started with the examples, we're going to basically be using two forms of quadratic equations. So first there's factored form. Okay, factored form is y equals a times x minus p times x minus q. And x minus p times x minus q. Hold on. My pen disconnected. There we go. It's x minus q. There we go. Where p and q are the zeros or the x-intercepts. Okay, so we use factored form when we're given the x-intercepts. Okay, there's also vertex form. All right, vertex form is y equals a times x minus h times, hold on, x minus h squared plus k, where h, k are the coordinates of the vertex. H is the x-coordinate, k is the y-coordinate. Okay, so we use vertex form if we're given, surprise, surprise, the vertex. Alright, so we're going to mainly use those two forms, and based off of what we're given in the picture is how we are going to, which form we're going to use. Alright, so in example 11, we've got the quadratic with a graph. So in part A, we've got two x-intercepts. We've got 3 and negative 1. So with those, we're given two x-intercepts, which means those are the zeros. So we're going to use factored form. So I'm going to go ahead and plug those in. Y equals a times x minus negative 1 times x minus 3. Okay, so it's going to be y equals a times x plus 1, that double negative, times x minus 3. Okay, that's great, except we also need to know what a is. Alright, so if we don't know what a is, we pick a point on the quadratic that we're given. So hopefully we're given a third point. In this case, we are. We are given the y-intercept. Okay, so the y-intercept is 3. That is the point 0, 3. So that's x is 0, y is 3. So we are going to plug those in for x and y in my equation. So y is 3 and x is 0. So I get 3 equals a times 0 plus 1 times 0 minus 3. Alright, so I get 3 equals a times 1 times negative 3, which is 3 equals negative 3a. Divide by negative 3. So a equals negative 1. Okay, so what do we know when the first coefficient is negative? We know that it is what we call concave down. It is opening downward, it is the upside down parabola. So if we have a negative here, we better have an upside down parabola up there in our picture, which we do. So we know we are correct in getting a negative. So my my quadratic equation is y equals negative 1 times x plus 1 times x minus 3. And that is sufficient. It doesn't tell me I have to write it in a specific form or not, so I'm going to leave it in factored form. Make my life easy. Alright, part B. This time we are only given one x-intercept. Okay, so when that happens, it is something called a double root. Okay, so this is a double root, which it basically just means that there's one root or there's two roots in the same exact spot. So how we'd write that in factored form, we have y equals a times x minus 2 times x minus 2. Basically, the 0 repeats itself, so it's called a double root. Or we would use y equals, pen issues. Y equals a times x minus 2 squared. Alright, so now to figure out what a is, we need to know what our another point on the graph is. So we also know our y-intercept this time. So that is the point 0, 8. So we're going to plug in 8 for y and 0 for x and solve for a. So 0 minus 2 is negative 2. Squared is 4. So we get 4a equals 8. Divide by 4. A equals 2. A equals 2. Okay, so we get y equals 2 times x minus 2 squared is our quadratic equation. Alright, so that's how we would do those two. Alright, in example 12, we are given one x-intercept, the axis of symmetry, so like the exact middle of my graph, and again, the y-intercept. Alright, my y-intercept. Alright, so for this one, we are also going to use factored form. Now you might be asking yourself, why are we doing factored form or screaming at me through your computer screen? Because you don't know the other y or x-intercept. Well, we're going to find the other x-intercept. Okay, so factored form again is y equals a times x minus p times x minus q. Alright, so for that, what we're going to do is, well, we know that x equals 1 is the exact middle of the graph. So between negative 2 to 1 is 3 units. Okay, so since between negative 2 to 1 is 3 units, that means from 1 to whatever this 0 is also 3 units. Also 3 units. Alright, so from 1 plus adding 3 units gives us a x-intercept of 4. So we have y equals a times x plus 2 times x minus 4. Plug in our x-intercepts there. Okay, now we're going to do the same thing. We've got our y-intercept of 16. So we are going to plug in 16. Maybe. See if my pen sometimes wants to work and sometimes doesn't. There we go. Plug in 16. So we got 16 equals a a times, remember we plugged that in for 0, 16, so we plugged that in for y and 0 for x, so we get 0 plus 2 times 0 minus 4. So we have 16 equals a times 2 times negative 4 times negative 4 Okay, so 2 times negative 4 is negative 8. A equals 16, divide by negative 8. A equals negative 2. Okay, so we've got our quadratic equation, y equals negative 2. Remember, if that's negative, we better be opening down in our picture. We are, so that's good. So we have y equals negative 2 times x plus 2 times x minus 4. That is our quadratic equation. All right, next. So in example 13, we are given a description. We no longer have a picture. So given a description of our quadratic. So we're going to find the equation of the quadratic whose graph cuts the x-axis at 4 and negative 3, and which passes through the point 2, negative 20. Give your answer in the form y equals ax squared plus bx plus c. So that is general form. We've got y equals ax squared plus bx plus c. So we need to put our final answer in that form. That doesn't mean that we can't use the other forms to get there. All right, so what am I given? I am given where the graph cuts the x-axis. Those are the zeros. That's where it crosses the x-axis. So I have zeros at 4 and negative 3. And so which form do we use when we have zeros? Right, so we use factored form. So we have y equals a times x minus 4 times x plus 3. Okay, and then we need to figure out what our a is. Only this time we're not given the y-intercept, we're given a different point, but that doesn't matter. We're just going to plug in 2 for x and negative 20 for y. So negative 20 equals a times 2 minus 4 times 2 plus 3. Right. So go ahead and solve for a. I got negative 20 equals a times negative 2 times 5. Negative 2 times 5 is negative 10. So negative 10a equals negative 20 divided by negative 10. A equals 2. So I've got y equals 2 times x minus 4 times x plus 3. All right, now I need to write it in general form, which means I need to multiply all of this out. So where it gets ax squared plus bx plus c. All right, so in order to do that, I can do it one of two ways. I can multiply the 2 by the x minus 4, or I can multiply x minus 4 times x plus 3, and then multiply everything by 2, which is what I'm going to do. So I have y equals 2 times x is x squared. X times 3 is 3x. Negative 4 times x is negative 4x. Negative 4 times 3 is negative 12. Right, so I got 2 times x squared, combine like terms, minus x minus 12. Multiply everything by 2, so I have y equals 2x squared minus 2x minus 24. There is my general form quadratic equation. All right, example 14, last one. We're going to find the equation with the quadratic with this graph. All right, this time we're not given the zeros, we're given the vertex. So we've been using factored form for all of these other examples. Now we're going to use vertex form. So let's remind ourselves y equals a times x minus h squared plus k. Remember, these are the coordinates of the vertex. Okay, so the vertex is x coordinate is h, the y coordinate is k. So I'm going to go ahead and plug in those coordinates of my vertex. So I have y equals a times x minus 3 squared minus 2. All right, now I need to find out what a is, just like the other problems as well. I'm given a third point on my graph, so I'm going to go ahead and use, actually a second point in this case, the y-intercept of 0, 16. Plug in 0 for x and 16 for y. So I get 16 equals a times 0 minus 3 squared minus 2. Okay, make sure you follow the order of operations. And you're doing this part first. So that's 0 minus 3 is negative 3. And then you're squaring it, which is going to be 9 minus 2. So I got 16 equals 9a minus 2. Add 2 to both sides. I get 18 equals 9a. Divide by 9. A equals 2. So my quadratic is y equals 2 times x minus 3 squared minus 2. Okay, I don't have to write it in general form, so make your life easy. Keep it that way. All right, last one. This time we're given the vertex. So again, we're going to use vertex form. But this time we're not given the y-intercept, we're given an x-intercept. Cool. So really we could use either form. We can, use the axis of symmetry and find the other 0. Okay, or we could just use vertex form since we're given the vertex. Either way, I'm going to use vertex form because we're given the vertex. It's a little bit less work. I don't have to try to find a 0. Okay, so we got y equals a times x plus 4, because we would be minusing negative 4, which makes the double negative, makes it a plus. So y equals a times x plus 4 squared plus 2. All right, so this time I'm given the x-intercept, which is the point negative 2, 0. So this time I'm going to plug in negative 2 for x and 0 for y. So I get 0 equals a times negative 2 plus 4 squared plus 2. 0 equals a times negative 2 plus 4 is 2 squared plus 2. So 0 equals 4a plus 2 minus 2 on both sides. So I get negative 2 equals 4a, divide by 4. So a equals negative 1/2. All right, it's negative, concave down, it's good. So my quadratic is y equals negative 1/2 x plus 4 squared plus 2. That's my quadratic equation. All right, so those are the notes for 2D. If you have any other questions, let me know. If you have other notes you want me to actually write out like this, also let me know. Have a great rest of your day.